Hi everyone, I'm Jared.
And I'm Andrey.
And we're part of the Front Range Ozone Experiment, or FROZÉ, this summer.
We are out here measuring ground level ozone and its precursor compounds along the Colorado Front Range.
And we're driving our Chevy Tahoe, or the CSU Plume Tracker, and we're gonna show you guys some of the inside stuff, some of the instruments, and give you a little tour. Hey everybody, this is Jared. I'm here out in Dacono, Colorado. Little sign right over there. We are here for a drive for ozone, and we're actually looking at a disproportionately impacted community in Dacono that we're going to drive around with our plume tracker, and we're going to take a canister sample to see what's in the air, and then we're going to drive toward Platteville and then back to Fort Collins to see the ozone gradient for today, because it's pretty hot out. And there's lots of precursors floating around, and so we're basically just quantifying the amount of pollution that different communities are being exposed to, as well as just the northern Front Range, well, the Front Range especially, but today the northern Front Range of Colorado, just to see how the pollution is getting affected. So here is our plume tracker. This is a Chevy Tahoe, and it's outfitted with various instruments that we'll introduce to you in a minute. But essentially these instruments measure different precursors and ozone as well directly. And yeah, we're gonna introduce instruments to you guys in a second, but just a quick overview. There's the LICOR. This is a 2B NOx instrument. This is teledyne caps that measures NO2. And then moving around to this side, this is the aroma. We've spent lots of time together, me and this one. And this measures VOCs. And then we have the palm over there in the corner. You can see it right by the seat. That measures ozone. And then we've got a mast here. So this is the S-Pod up front that also measures VOCs, which just kind of gives us like one number. It's kind of like a qualitative measure to see when we want to pop a can. And then that top part is the AirMar, and that measures wind speed, wind direction, and it also has GPS.
So these two instruments over here measure nitrogen oxides, or NOx. They both have a laser in them that shines a light, and then the gas absorbs that light, and that's related to the concentration. So the instrument up here we have measures methane and CO2, also with a laser. So these are very fast instruments. They measure these compounds at about 1 second time resolution. So we can get good coverage of the data as we drive around. And this is the aroma VOC instrument, which measures different volatile organic compounds. All right, in here we have our personal ozone monitor. It's a very small instrument, but it measures the concentration of ozone in the air through light absorption. And other big thing in here is our battery, which we use to power all of these instruments.
A whole air canister. It is 1.4 liters big, and so we essentially pop these in different neighborhoods, or just generally any area where we see plumes. And so we measure about 50 volatile organic compounds, about 50 species. And so with that measurement, we basically inject this into a gas chromatography system, and then that speciates the different compounds in the can. And then we basically can see the amounts, the concentrations of these different compounds in various areas. And so that might be of interest for things like benzene, potentially, which is a carcinogenic compound. So we can basically quantify the amount of pollution that people are exposed to, as well as the amount of precursors that are available in a certain area for ozone, and kind of just look at gradients across different areas. And so you basically just pop a little thing on top of this. It's a vacuum inside. Then as soon as you open it, the air enters the canister in about a minute. It's really quick. And then we can see what's going on in the air. Here in Longmont. It is currently 2:33 in the morning, and we have a can here. We are currently in a disproportionately impacted community, and we are going to collect a sample of air. The reason why we're here so late at night is because it's easier to track plumes, because it's cooler, the boundary layer is much lower, and so we just put this little cap right here on top of this little can, and then we'll just lift it up and collect the sample, and we always wear headlights for safety because it's so dark.